Um, oops. So if you remember the last time we met, we did that activity called Is Cereal a Soup? And again, the purpose of that activity was to tell us what the importance of definitions are in general, but especially in math. It's really important to have a clear definition that you can work with. There's no ambiguity. How do you define cereal? How do you define soup? Based on those definitions, is cereal a soup? So we're going to use some very fundamental definitions right now to help us practice with the concept of direct proof. Okay, so we have this definition. An integer is even if it can be written as 2q for some integer q, and odd if it can be written as 2q plus 1 for some integer q. Now, there's an important note right here. In fact, I think I'm going to highlight it. Notice they're using the letter Q in the definition, but there's nothing special about the letter Q. I could have written the definition with K instead of Q, or N, or M, or L, or S, or T, or U, or V, or even a Greek letter if I wanted to. The point is, these letters you find in definitions are just placeholders. You could call it whatever you want. Let's look at another definition. It says, let m be a non-zero integer. So within the definition, we're actually defining m as a non-zero integer, but that's not the definition they're trying to tell us yet. The definition is, an integer is said to be a multiple of m if it can be written as mq for some integer q. So as a super quick example, if I have, let's see, if I have, I can say that 15 is a multiple of 5, since 15 can be written as 5 times 3. Let's take a look at how that relates to the definition. We always want to take the letters in a definition, and when we have an example, we want to figure out how do these numbers match up with these letters, like which number here plays the role of which letter in the definition. It's really important to practice doing that. So I have, let's see, 15 is a multiple of 5. Okay, so I see multiple of 5 and I see multiple of m, so that means I can conclude that 5 is playing the role of m in my definition. So that's my m here. And then, let's see, I have the 3 here and I have the 15. So the other letter is Q, which means Q is either the 3 or the 15. So let's read again and see if we can figure it out. So an integer is said to be a multiple of m if it can be written as mq for some integer q. So I'm seeing two integers multiplied together, and one of them is m, so the other one must be q. So this integer must be playing the role that q plays. Okay, so where's the 15 in this definition? It turns out the 15 is an integer. They didn't give a letter name to that integer. And sometimes they don't give a letter name to everything that they mention in a definition, but you do still need to know what thing is playing which role when you're reading and trying to understand definitions. Okay, so let's look at an example. It says, show that the square of an odd integer is odd. So that tells me I'm going to have to pick an odd integer. So I have to pick an odd integer, I have to square it, and then I have to somehow argue that it is odd. The result is odd. Okay? Notice the way they start the argument. Let n be an odd integer. So let's see. Let n be an odd integer. They're referencing this integer that we're going to have to square. But before they do the squaring, they use the definition of odd to rewrite n in a way that will hopefully be more useful. N equals 2t plus 1 for some integer t. Notice they're not using q, but that doesn't matter. They're using t instead of q. But again, the t is playing the same role that the q does in the definition of odd we have at the top of the page. All right, so when we take the square of this odd number, that'll be n squared, which means it'll be 2t plus 1, quantity squared. We work that out, we get 4t squared plus 4t plus 1. And what we want to do with this is put it in the form 2 times some integer plus 1. Okay, so we want 2 times some integer plus 1. And if you notice, that's exactly what we get here. You take the first two terms, 4t squared plus 4t, you notice that you can factor out a 2, and you go from there to show that n squared has the structure of an odd number. And notice, for writing purposes and clarity and specificity, as we've been talking about, it's not just showing us the math and then done. It says where 2t squared plus 2t is an integer. So remember, this stuff in the parentheses has to be an integer, so we need to say that it's an integer. And it is an integer. We know it's an integer because when you take an integer t, you square it, multiply it by 2, it's still an integer. If you add 2 times that integer t, it'll still be an integer. And then they write the conclusion. Hence, n squared is odd, which is what we wanted to prove. Give the hands-on exercise a try, pause the video, and I will rejoin you shortly. It says let n be an integer. Show that if n is odd, then n cubed is odd. Give it a try, pause the video.